mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
All right, calculus students, I've had a few questions on the assignment that I assigned out of your textbook from page 358. So we're going to spend a little bit of time going over some of the questions. If we go over them and you still have questions, make sure you ask, and I can go through them in a different way if necessary. But we're going to start with question number 9. Question 9 was the integral of cos x over 2 minus sine x dx. So we're always going to try substitution first. So if I let u equal to 2 minus sine x, the derivative of that du is negative cos x, right? The derivative of 2 is 0 minus the derivative of sine x, which is cos x dx. Okay, dividing both sides by the negative 1, we get negative du equals cos x dx. We make the substitution, we pull the negative 1 out front. This is the integral of 1 over du, right? Du over u. Now we use our integration rules from our formula sheet. It's the integral of 1 over u equals to the natural log of the absolute value of u plus c, and the negative sign stays out front. And then we just reverse our substitution to finish up. So the negative natural log of 2 minus sine x plus c. Okay? So we're just using substitution to make that happen. Let's go do question 11. So here we have question number 11, and we have t over t squared plus 5 dt. Again, we try substitution first, and again, we're going to let u equal to t squared plus 5, which means the derivative is 2t dt. Divide both sides by the 2, and we have du over 2 equals t dt. And again, what we're looking for in substitution is we're looking for our interior function, so that when we take the derivative, we get the other piece, right? And so when we do that, here you see t dt will get substituted out for du over 2. All right, so there's a 1/2 here. The constant 1/2 comes out front, leaves us with 1 over u, replacing the t squared plus 5 with u, du. Again, it's the same integral we just did, so it becomes 1/2 the natural log of u plus c, or 1/2 natural log of t squared plus 5. Okay, so it's the same integral in the end, starting with a different substitution. Let's go back and do the next question. The next question we're going to look at is number 13. So again, here's question number 13. It's the integral of the tan of the natural log of y over y dy. Try substitution again. Substitution. We're going to let u equal the natural log of u because the derivative of that is 1 over y dy. And if you look here, we have a 1 over y dy that we're going to substitute out. Okay, so the natural log of y becomes u, our 1 over y dy becomes du, leaves us with the integral of tan u du. That's a formula on your formula sheet. Use it. We get the negative natural log of cos u. Replace the u back with the natural log of y, and you're all done, leaving us with negative natural log of cos of the natural log of y plus c. Okay, question 15 is next on the other board. And so here is question number 15. We have the integral of dx, or 1 over x, natural log dx. All right, again, substitution, start with that. We let u equal the natural log of u. That means du is 1 over x dx. Here's our 1 over x dx, and here's our natural log. If we make the substitutions, we'll be left with the integral of 1 over u du, which is an integral we've taken twice already in this video. So it becomes the natural log of u plus c, or the natural log of the natural log of x plus c. All right, so sometimes it is tricky to find what you should substitute for. but you've got to keep trying, and the more you do, the better you'll get at it. We're going to do one more question, which is not a substitution question, on the next word. All right, this last question is number 19, and this question, I've done most of the work on the board already, and we'll walk through it, and then we have to finish it up by showing you something that is not intuitive. It is something that you have to kind of pick up through experience and recognizing what it is you're solving for, and remembering that and noticing it. So we'll talk about that when we get to the end. So the question starts with the integral of e to the 3x times sine x dx. If you think of trying substitution, it's not going to work. For substitution, you're either going to let u equal to 3x, in which case the derivative is 3 dx, which means we don't get rid of the sine. And if we let u equal to sine x, or just x, again, we don't get enough of the parts. We can't substitute away all the parts, so substitution is not an option for this one. And so we're going to do integration by parts. And so for integration by parts, we start by selecting a u. So here I've selected u equaling e to the 3x, and we start by selecting a dv, so the other part is sine x dx. Okay, so we're recognizing u and dv. Okay, now we take the derivative of u, which is 3e to the 3x. Again, if we're doing it, we're using our chain rule. And so e to the 3x is e to the 3x times the derivative of 3x, which is 3. So we just pulled that 3 out front, and we have 3 e to the x dx. The integral of sine x is negative cos x. Again, it's on your formula sheet. All right, now our integration by parts formula is u times v minus v du. Okay, so I've written that down. Here in this line, all I've done is simplified it a little bit. I pulled this negative sign out front, so it gives me e to the 3x times cos x. Here I've taken this negative sign and moved it out front, which changes it to a plus, and I've taken the 3 and moved it out front. All right, that leaves us with the integral of e to the 3x cos x dx. Again, we now have to integrate this by parts again. So again, we're going to select a u and a dv. And you can see what I've done here. Again, u was e to the 3x, du is the 3e to the 3x dx. I've forgotten the 3 there. There we go. All right, and the integral of cos x dx is sine x. And again, we're going to go back and we're going to do the same thing that we just did, which is to, okay, we've got our negative e to the 3x cos x plus, here's the 3, and now it's u times v minus v, the integral of v du. All right, and then what I did in this step is I multiplied this 3 through the square brackets. Okay, so the negative e to the 3x cos x doesn't change. Here's the plus 3 multiplying through the brackets. Now we get 3 e to the x sine x minus, here's the minus, and then I pulled this 3 out front and multiplied it by this 3 to get 9. Okay, and then I rearranged the order in here. I have my e to the 3x, my sine x, and my dx. Now here's where we have to recognize something. The question was, and so this all equals to our question, which was the integral of e to the 3x times sine x dx. Well, look what we have here. We have the integral of 3 e to the 3x sine x. I'm going to add this negative 9 integral to both sides. And if I do that, I have 1 integral of e to the 3x sine x dx, and I have 9 over here. If I bring it over, I'm going to get 10 integral e to the 3x sine x dx equals what's left here, which is negative e to the 3x cos x plus 3 e to the x sine x. All right, and so now to solve for what our question was, which is right here, we're simply going to divide both sides by 10. That will cancel out, and we'll divide all of this by 10, add a c, and we're all done. Okay, so that's it, because the question was find the integral of e to the 3x sine x, and that's what I have here. Now I have e to the 3x sine x equals this statement. But the trick comes in recognizing that when we got to this point here, we had our question here again, right? And so by remembering that that's what we were solving for, here it is again. I can collect my like terms, because they are like terms, and get that. That is a tricky question. It is a hard question. It is something that you will only get through doing lots and lots of questions and through experience. And so we'll do a few more similar to this year as we wrap up this unit. But really it's going to be as you move further in calculus and just get more experience with calculus, noticing those kinds of things will become easier. It is hard. I know it's hard. That's okay, right? If it was easy, as I've said many times, if it was easy, everybody would do it. But because it's hard, only the special few of you are doing it. And so keep going, keep practicing, keep getting experience, and it will get better. All right, that's it for today. Those are the questions that were asked so far. If you have other questions as we move forward, please make sure you email me, and we'll go over more questions going forward. Have a good day.